Welcome to a demo on outlier detection. In this video, I'm going to show you the top 10 ways to detect outliers. I will take data related to tweets for Apple stock. The data is pretty straightforward. You have the date, you have the number of tweets on that day, and our mission is to find out the days on which the number of tweets were different or unusual from others. I'll be using 10 different methods to find outliers. Now, these methods range from various approaches such as visual inspection, statistical methods, dimensionality reduction, clustering, machine learning, and neural networks. Now, each of these methods has its own advantages and its disadvantages. And this video will help you get a complete overview of different methods as well as understand the value of each one of them. Let us now start with the visual approach. And here is the line graph, which has got the number of tweets plotted against time. Now, one simple way is to eyeball all the peaks. And you can conclude that there were exceptional number of tweets at this point of time. Now, though it's a very simple approach, but it is quite manual. For example, should we consider these peaks as outliers or not? It's based on human judgment and is not scientific. Let us now go to the second method, which uses statistics to determine the outliers. Now, in this approach, also called as the box plot approach, the center of the box represents the median value, and the box represents 50% of the values from the median on either side. And then we can make some lines or whiskers, which is at a certain distance from the edge of the boxes. And all the points which are lying outside these lines are called outliers. Now, here is the box plot of the number of tweets. The width of the box is very less, meaning that most of the values are very close to the median. Now, the green dots are considered as outliers. And we can roughly say that if the number of tweets is more than 159 or so, then it represents an outlier. Now let us plot this outliers on a time series plot. So I will try to put some markers which represent outliers, and wow, there are markers everywhere. Now, generally speaking, outliers means something exceptional, so it should not occur a lot. However, the box plot approach shows that outliers are occurring almost every day. Now, the reason is that the width of the box is very short, and most of the values are very close to the median value. So this approach is definitely more scientific than the visual approach, but it can give a lot of outliers which may not be desirable. Now let us go to the next approach, which is based on dimensionality reduction. Now you might say that there is just one value dimension, which is the number of tweets. So how can we reduce it further? Well, my friends, the trick here is to add some dummy dimensions, and we can add two columns which have zero value, and then we'll try to reduce 3 dimensions to just 1 dimension. And now here is the result of the dimensionality reduction, and it essentially works by separating points as far as possible on the highest varying dimension, which is the number of tweets. So here we see that there are some points which are separated away from the rest, which are shown here in bluish color. And let me now filter based on the color. And here we see that we have our outliers shown over here, and which is essentially all the values which are above 2826. Now, let us try to plot them on the time series plot. And let me go ahead and select the points which are marked as outliers as per the PCA method. Nice. We see that not everything is selected. And also, unlike the visual approach, there are both higher and medium peaks are also selected. And this visual gives us a true sense of outliers. However, there is still some manual work which is involved. This is when we try to visually separate out the points from the others. Now, let us go to the next approach, which is the K-means clustering. Now this algorithm will cluster points close to each other in one cluster. And then instead of visually eyeballing, we can directly select the cluster which is far from the rest. So here is the result of clustering, and I have divided all the points into 5 clusters. And let me now deselect the cluster 2 and cluster 3. So we are left with the very low values, which are shown here by cluster 0, and then moderately high values, which are shown here by cluster 4, and very high values, which are shown here by cluster 1. Now, the advantage of this approach is that you can also separate out the very low values in a separate cluster, which can also represent outliers. Now, let us see on how they show up on the time series plot. So let me now select the cluster 1, which is the very high values. Now let me go ahead and select the cluster 4, which is the moderately high values. And then if needed, we can also select the cluster 0, which represents very low values. So you can also increase the number of clusters to fine tune your outlier selection. Now let us go to the next approach, which is called as DB scan or density based clustering. Now the advantage of this approach is that you do not need to specify any cluster, but it will automatically find a cluster based on the dense areas. And all the points which are outside the dense areas are the outliers. Now here is the result of DB scan, and all the points which are indicated as cluster -1 are outliers. Now let us try to plot them on the time plot. And let me go ahead and select the points which are marked as cluster -1. Voila, I see all the outliers which are moderately high as well as high values. So here I do not need to select different clusters. I have all the high as well as moderately high values in one go. However, you might not have the possibility to separate out the very low values as we saw in K-means. All right, my friends, let us now move to the next approach, and hopefully you're enjoying the video till now. If yes, please to hit the subscribe button, and let us now go to the next interesting approach, which is called as a hierarchical clustering. Now this is similar to K-means, but it forms an hierarchy of clusters. And outliers may be detected by examining the structure of the hierarchy. For example, here we see that we have a deeper node, but over here we see that the node is not that deep, indicating the leaves, or let's say the endpoints of this node are outliers. So we can also hover over these endpoints, and we see that the tweet values are more than 10,000, which is indicating that these are very high values and are outlier values. So till now, all the approaches which you've seen are based on clustering and statistical approaches. And what we had tried to do is we try to cluster the points, and whatever is outside the clusters are outliers. However, let us now look at the algorithms which are specializing in finding outliers directly. So let us now move to the next approach, which is called the isolation forest. Now, isolation forest tries to locate points which are isolated compared to others. And here is the result of isolated forest algorithm, and all the points which are marked as outliers, and all the points which are outliers are marked as outlier equal to 1. Now, one advantage of this method is that it also gives a score, and all the score values which are negative are outliers. Now let us try to plot them on a time plot, and let me now go ahead and select the outlier equal to yes, And yes, this gives me a very good idea of outliers. It is direct. I do not need to bother about clusters, and I have my outliers. All right, my friends, let us now go to the next approach, which is called as the local outlier factor, or the LOF. Now here the outliers are those which have significantly lower density compared to the neighbors. So here is the result of LOF, and all the points which are shown here in blue color are the outliers. Now these points are outliers because they do not have enough density compared to its neighbors. Now let me filter and just keep the outliers, and we see that you have high and moderately high points, but you also have the very low values. Now this is very powerful compared to isolated forest because it also shows outliers on the lower side. Now let us see on how it looks like on a time plot. Let me go ahead and select the outliers. Wow, you can now see that it has selected the very high values as well as the very low values. And these values, they have less density compared to the middle values. Now, unlike clustering, you do not have to select a separate cluster for high and low values, but you get the outliers directly in one shot. Now, my friends, let us now change the gear and go to machine learning techniques to detect outliers. Now, one of the very popular machine learning techniques is called as one class SVM. Now it tries to divide all the points into two classes and places a boundary between the two classes. The class which has got most of the points are normal values, and the other class is the class with the outlier values. Now shown here are all the points, and the x-axis is the number of tweets, and the y-axis is the score which is given by SVM. Now the score value helps us to visually see different groups of points, and we can decide on how to define an outlier. Now in this example, let's say all the points which are below the score of 1000 are outliers. And let us see on how they look like on the time plot. So let me go ahead and select the outliers, and the outliers seem to have been correctly captured. Now, the biggest advantage of HVM is that now you have a machine learning model which can be used to predict outliers on a continuous basis. All right, so now let's go to the last approach, which is based on deep learning autoencoder architecture. Now, autoencoders are a type of neural network that tries to learn to encode input data into a lower dimensional representation and then decode it back into the original input. And outliers can be detected by observing the reconstruction errors. The instances with higher reconstruction errors are more likely to be the outliers. So here you see all the values and the reconstruction errors in percentage. And if we take all the values which have 5% or more reconstruction errors, and then if we try to plot them on time plot, we will get our outliers. So it's a very sophisticated approach, but it can be very useful for very complex data sets. All right, my friends, hopefully you have enjoyed the video till now. If yes, please do hit the subscribe button and comment which is your favorite method. Now let me show you on how you can access the demo using my platform experiencedatascience.com. So this website, you'll be able to learn data science using various demos. And let us start with the outlier detection and analysis. So let me go ahead and go select it. And here you will see the Twitter volume data set for Apple. Of course, you can always hover over the tip button to see what to do at each step. So let us first go ahead and select this and copy it and make it ready to use. All right, so the data set is now copied. No, just one important information is if you want, you can also add your own data. using this add button, but for the moment, let us go ahead and select this Twitter data set. And here I see three tabs, the data display tab, the k-means, and the isolation forest. And let us first start by displaying the data. And let me go ahead and select few columns, and let me go ahead and execute this. All right, so now you see the data, you see the timestamp as well as the value which indicates the volume tweets on that particular day. Let us go ahead and do the k-means. And here you can select the value as the column on which you want to do the k-means clustering. Let us go ahead and select the number of clusters as 5. And for visualization, let me just go ahead and select a value, right? So that it's easy to visualize it. And of course, I can go ahead and also save the data set. And let us now execute. Right, so now I see the results and I can see all my different clusters. Now, as I've chosen the X and Y axis to be similar, which is equivalent to the volume of tweets, I see a line which goes like this. But here, the cluster number 1 is in fact our outlier. As well as if you want to select the outliers on the very low side, it is the cluster 0. Of course, you can always download this data and you can see it in the Excel format. Now, let us go ahead and do the isolation forest. Now, let me go ahead and execute. Now, let me go ahead and execute this particular algorithm, and let me select the value on which we want to make the isolation forest. I will just select few values to show on X and Y axis, and to be simple, let me just go ahead and select the value which will be shown on both on X and Y axis. Now, for the isolation forest, you need to set up a contamination factor, which is an estimate on what is the percentage of outliers or anomalies what you're expecting. Now, if you're not sure, you can enter -1, but let me go ahead and enter a very small percentage because I estimate that the outliers will be not that much. So let me go ahead and enter, for example, 0.001. And let me set up some other parameters and let me now execute this. Now here I see my results, and all points which have been identified as 1 are my outliers as per the isolation forest algorithm. All right, my friends, so hopefully you enjoyed the video. Please go ahead and try out experiencedatascience.com, and you'll be able to understand very easily without any coding all different algorithms which are related to outlier analysis and much, much more. Thank you for watching and see you soon in the next video.